Hi everybody. It's been a while since the last video, but it's been a lot going on personally. Displaced Texans has become even more displaced than we were before. We've moved from Sioux Falls, South Dakota to beautiful San Diego. Stay classy, everybody. So I'm going to start taking you through how to do the Gridfinity base plate. And what that's going to look like is we're going to implement a pad to start with, and that's going to be our outline. And then we're going to do some subtractive lofts to work on the stacking lip of the base plate. So to start off, we're going to create a part. And I'm just going to name this base plate. And to do anything inside of a part, you need a body. So just going to rename that to base plate body. And to make this thing fully parametric, what we're going to need to do is implement some variables. And our first variable is going to be called, just to initialize something, because I want to do something fancy once I'm inside here. So we're going to rename this to baseplate variables. Now, I don't want to keep that variable there anymore, so I'm just going to remove it. Now, what I'm going to do this time is create variable groups. So I'm going to name this variable group Gridfinity. And I'm going to change data type to integers, because this is where I'm going to store my unit values. So I'm going to start off with X units right there. And you can see it's in this group named Gridfinity. Now I'm going to add one more property, and you probably guessed it already that it's going to be Y units. I'm going to initialize that to 1. And because we're working with base plate, there's no real reason to implement height units, because there's no height really associated with the base plate. So that's all my Gridfinity units. Now I'm going to switch back to the length property, and I'm going to rename the group again to offsets. And right now what I'm going to implement is the variables for these offsets here being 2.15, 1.8, and 0.7. So I'm going to start with plate offset, and that's going to be plate offset 1, because there's 3 offsets. And you see again, there's an offsets group here now. So just to make things easier on yourselves, what I'm going to do is just hard code a single value into the expression editor, and that'll mean that it's less difficult for you to accidentally overwrite a value later on. So we're going to say 2.15 millimeters. Always remember your units, otherwise I think it's in pixels by default, so you don't want 2.15 pixels at all. And now that's blue, saying that it's hard coded, and I can't accidentally type anything right there. So I'm going to do that for all of my variables. And now I'm going to go to plate offset 2. And once again, it's going to be 1.8 millimeters. That's blue once again. Now one more property, plate offset 3. And that's going to be 0.7 millimeters. Now there's 2 more offsets in the offset group. And that's going to be our grid pitch, so that 42 millimeter pitch of the Gridfinity system. And now that's blue because it's tied to the variable or to an expression. And I want to add one more. That's going to be hole offset. Here it's going to be 4.8 millimeters because it's going to follow our offset of this hole here. So there we go. And I'm going to keep going with all my properties now. So I'm going to stay with the length variable type, and I'm going to rename this group fillets. I want to call it fillet diameter 1. So again, a fillets group has been created, and I'm going to call this 8.8 millimeter diameter because I'm generating this fillet first, this base plate outer fillet. Now, I'm going to keep going our fillets group while we're here, and I'm going to call this fillet diameter 2. And the interesting thing that I can do here is I can just say fillet diameter 1, and I want to subtract the value of our base plate offset 1 to obtain this. And because that's going to be a radius, we need to multiply by 2. So here we're going to have 2 times plate offset 1 for 3.7 millimeters. Okay. And that seems to be correct. Now, we're going to go to fillet diameter 3. And similarly to our other offsets, we're not actually moving in the X direction at all, it's just in the Y direction. So we're going to subtract. We're going to create another expression. This time we're going to say fillet diameter 2. I can't rename this, so I'm going to have to delete it and add the property again. There we go. That's better. Now, fillet diameter 2. And like I was saying, we're not moving in the X direction for this 1.8 millimeter offset. We're only moving in the X direction for this 0.7 millimeter offset. So that means we're only going to subtract plate offset 3 for a 2.3 millimeter fillet diameter. And that's all my fillets labeled and created for our variables. So I'm going to move on to the hole variables, which means I'm going to rename that property group to holes. And I'm going to start with magnet depth. And similarly to the base plate, this magnet depth is going to be 2.1 millimeters. And once again, similar to the base, the box, not the base plate, we're going to implement the magnet diameter. That's spelled correctly. And we're going to make that 6.5 millimeters because we're really designing the base plate to allow for magnets to be implemented so you can magnetically attach your Gridfinity box to your Gridfinity base plate. Likewise, we're going to implement screw holes in case you want to add screws to your Gridfinity base plate to attach your boxes or what have you. So we're going to start with screw depth. And our screw depth is actually going to be twice our magnet depth. So that's exactly what we're going to say here. We're going to say magnet depth times 2, and there that's 4.2 millimeters. And here we're going to have screw diameter. Oh, no, I don't want to add the property. I just want to edit the expression. And similarly, it's going to be 3 millimeters. And that should be all of our variables implemented so far. So now what I'm going to do is I'm going to select our, oh man, today is not my day for typing. So I need to rename that to spell baseplate body correctly. Now, with baseplate body selected, I'm going to create a sketch, and I want this sketch to be on the XY plane. So that's selected there. And now I can create my sketch. And for this outer body, what I'm going to do is I'm going to create a 2-corner rectangle. And I don't actually want that to be a rounded rectangle yet. I'm going to implement the fillets myself. So here we have it. There's our rectangle. And we're basically going to dimension this rectangle exactly the same as we dimensioned the outside of our Gridfinity box pad last time. So what we're going to do is we're going to go to our expression editor, and we want to say, we want to reference our base plate variables. We want to reference the variable x units for our x value of our box outline. And we're going to multiply that by, we're going to need to reference our variables again, and we're going to need to say grid pitch. So that's going to be 42 millimeters since I've initialized everything to a value of 1. And I'm just going to rename this to X length. I shouldn't need that name, but it'll be easier to have that named if I do. And this time, I'm going to implement my Y units. Same thing, reference our variables, Y units times variable reference once again, grid pitch. And here I'm going to say Y length as my name. And there's our sketch. So I'm going to close this sketch out. And go into an isometric here. Now I'm going to select this sketch. And I'm going to rename it to plate outline. And what I'm going to do is create a pad here. And the length of this pad is going to be the height of all of this. And what I'm going to make that is we're going to reference our base plate variables. And we're going to add our plate offset 1 for 2.15. And we're going to add all of these numbers together to create that height that we want. So plus variables once again, plate offset 2, add one more time. I'm going to resize my expression editor window And I'm going to say variables once again, plate offset 3. And looks like we have the proper value because it says here approximately 5 millimeters and we've got 4.65. Seems to be okay to me. So I'm going to click OK. And I'm going to rename this to plate volume. Now, if you see here, we see some filleted edges. And what I've just realized is that I have not filleted the sketch properly. So I'm going to go back here and I'm going to edit this sketch. I'm going to press GFF on the keyboard and I'm going to select some filleted edges here. And you'll see why it was important to constrain by points instead of by line, because these points still exist as construction geometry for the sketch to fillet. And if we had dimensioned by the line, that line's now shorter and it would have messed with our dimensions here. So it's in FreeCAD, it's good practice to always dimension by points whenever possible instead of by line or other feature type. So I'm going to right click to get out of that tool. And now I'm going to press E on the keyboard for equals constraint. I'm going to make all of these equal, all of these fillets here. And with all of them equal, I'm going to right click once again. And now I'm going to press KO to dimension a diameter. I'm going to go to the expression editor. I'm going to reference our variable group. And I'm going to say fillet diameter 1 of 8 millimeters. And with that properly dimensioned to 8 millimeters, it looks like a square. It should be a square. We still have 42 millimeters and 42 millimeters. I'm just going to resize this so you can see it or move it around. And I'm going to close this sketch. As you can see, our pad updated. So this is an example of why it's very important to properly name something in your model tree so you can find it immediately and edit it if you've made a mistake or need to make a design revision. And with that, I'm going to sign off. But before I do that, I'm going to go to my baseplate variables and test that it is actually fully parametric. So I'm going to type arbitrarily 5 for the x units, and that updated in the x direction. 3 for y, that updated in the y direction. And let's reverse it, why not? We'll go 5 units in the y, 3 units in the x. Everything's still updating properly. And there you have it. We've got a fully parametric pad that's going to be used as our baseplate outline. And in further videos, we're going to implement our stacking lip of the baseplate. Hope you have a great day and tune in for more.